Welcome back to Tales of Chemistry. In this episode, let us see the names of certain coordination compounds. So, our target today is to learn nomenclature. Let us begin with anionic complex. The meaning of this word anionic complex is the complex part of the coordination compound is negatively charged. That means the counter ion is positively charged. Let us take the example. First one, Na3CO NO2 6 times. Whatever is positive, that part will be named first. So here, sodium is the positive part. We will only write sodium. We need not write trisodium. Trisodium is not required. Whatever is the number, we will ignore it. We will just write the name of the positive ion. Moving into the square bracket, ligand should be named first. The ligand here is NO2. NO2 is an ambidentate ligand, which means the pair of electron of the ligand can be donated to the central metal through nitrogen or through oxygen. But when it is written NO2, it is evident that nitrogen donates the pair of electron to the central metal. The dative bond is formed from nitrogen to cobalt. So here the name is hexa. Hexa stands for 6. Then NO2 should be written as nitrito-N. So this capital N represents nitrogen as the donor. Then name of the metal, sodium hexanitrito-N, cobalt. But in any anionic complex, name of the metal should end with 8. So, sodium hexanitrito-N, cobaltate. Then bracket is opened here to write the charge of the central metal. Central metal here is cobalt. How do we calculate the charge? Sodium has +1 charge, right? Each sodium is +1. Each nitrito-N, NO2 is 1 minus. So, total positive charge is 3 plus X minus 6. Then the charge on the net complex is 0. So, 3 plus X minus 6 is 0. X minus 3 is 0. X is equal to +3. This +3 should be written in Roman numeral. So the name is sodium hexanitrito-N cobaltate 3. Next example is K3 Fe CN5 NO. Well, so let's begin. Potassium, not tripotassium, just write potassium. This number, it is balanced in the charge. Then, after counter ion, we are moving on to the ligands. There are 2 ligands. CN is a ligand, NO is another ligand. Now, CN is cyanido and NO. Okay, CN is cyanido. It is CN1 minus cyanido. And NO is nitrosonium. It is NO plus. It is nitrosonium. All right. So, when you name it, potassium pentacyanide. Okay, I'm continuing here. nitrosonium. The rest I'll be writing down, but the name is to be actually written as a single sentence or single word actually. Potassium pentacyanide, nitrosonium. The metal is ferrate. Open and close the bracket to write the charge, the coordination number. So I'm assuming this to be X. Each potassium is +1, each cyanide is -1, and nitrosonium is positively charged ligand. So the total charge is 3 due to potassium, +1 into 3, plus X, -1 into 5, -5, plus 1 is equal to 0. So 3 plus 1, 4. 4 minus 5, 1, right? X minus 1 is 0. X is equal to +1. So that +1 is written in a Roman numeral. Therefore, the name of the second compound is potassium pentacyanide nitrosonium ferrate 1. Now, next example, K3 Fe C2O4 3 times, thrice. Potassium. The ligand is C2O4. C2O4 is actually with the charge C2O4 2 minus, and its name is oxalato. Its name is oxalato. So potassium trioxalato ferrate. Name of the metal should end as 8. So ferrate charge. I'm assuming the charge on the metal to be X. This is +1. This is -2. So total charge +3 plus X -6 is 0. X minus 3 is 0. X is equal to +3. So here write that 3 in Roman numeral. So the name is potassium trioxalato ferrate 3. Potassium trioxalato ferrate 3. Next one is Na2 NiEDTA. Okay, so Na2 is sodium. EDTA is a ligand whose name is ethane 1,2 diamine. Ethane 1,2 diamine, then tetraacetate. Ethane 1,2 diamine tetraacetate. This is EDTA. And the structure of EDTA is, look at this, CH2 on either side of this N, and on N, CH2COO minus. CH2COO minus. This is there 4 times. That is why tetraacetate, CH2COO is representing acetate. It's repeating 4 times, tetraacetate, and this tetraacetate is present on ethane diamine. The charge on this is 4 minus. So charge on EDTA is 4 minus. Fine. Now, when I write the name, it is sodium. Then since the name of the complex, okay, is name of the ligand itself is complex. Let us be careful while writing the name. Sodium, ethane, 1,2 diamine tetraacetato. Acetato. This itself is the name of that ligand. Then the metal, nickelate. Okay, nickelate, not required to write the capital letter N. Ignore that. Small n is enough. Now the charge. +1 due to sodium, -4 due to EDTA-X. So 2 sodiums are there, +2 plus X -4 is 0. X -2 is 0. So X is equal to 2. So here, name is sodium ethane 1,2 diamine tetraacetato nickelate 2. Sodium ethane 1,2 diamine tetraacetato nickelate 2. Next example, K4 Fe Cn 6 times. Potassium. Here nothing new, so we can quickly write the name. Potassium hexacyanidoferrate. The charge. Now let's try doing the charge mentally. +1 due to potassium, 4 potassiums, so plus X, and this is X. And each cyanide is -1, 6 cyanides is -6. So X -2 is 0 and X is equal to +2. So Roman 2 is written. Next example, NaAuCN twice. So sodium dicyanide orate, Au, aurum, gold, orate, +1 -2, -1 per cyanide, but 2 of them, -2 X. So X -1 is 0, X is 1. Next example, Na2 Fe Cn5 NO. Sodium. Now, cyanido and nitrosonium is there. In alphabetic order, cyanido comes first. Penta for Cn 5 times. Okay, penta, cyanido, nitrosonium, ferrate, charge. X +2 -5 +1. So sodium pentacyanide, nitrosonium ferrate. The charge here is sodium is 2, 2 + 1, 3. Okay, 2 + 1 is 3, 3 and -5. So X should be equal to 2. So that is also done. Next one is Na2 Cr. So the metal is chromium. CH3COO 4 times. CH3COO is acetato, tetraacetato, and En. Now, sodium, tetraacetato. So alphabetic order, A comes first, acetato. Tetraacetato, En. So what is En? En is ethane 1,2-diamine. Ethane 1,2-diamine. Okay. Now, what we must do is write the name of the ligand. But since the name of the ligand has a di in its name, slight care has to be taken. Such a ligand whose name itself is complex should be put in a bracket. Ethane 1,2 diamine. Okay, so this is precisely because of the fact that there is a di in the name of the ligand. So we need to make sure that whatever is written in the bracket is a ligand. Ethane 1,2-diamine is a single ligand. Now, then the name of the metal, chromium, so chromate, and the bracket with the charge. +2, X, tetraacetato is -4, ethylene diamine or ethane 1,2-diamine is a neutral ligand. Ethane 1,2-diamine is a neutral ligand. Therefore, now this is sodium, the charge 2 and -4. Okay, so the net result will be actually -2, right? Na2, sodium, and tetraacetato. Acetato is -4, and ethylene diamine is 0. So the charge here has to be 2. Okay, Na2 positive 2 plus X -4 is equal to 0. So the charge is 2. The next one, K4, Ni, Cn twice, K4, NiCN twice, OH twice. Now, OH is something which we have not discussed. So this is OH1 minus. It's called hydroxido. Charge is -1. Therefore, now potassium, alphabetic order, cyanido will come first. Dicyanide, dihydroxido, nickelate, bracket, +4, X, -2, -2. Now look at the charge here, +4 and -4. So X is 0. It's absolutely fine to write the charge as 0. This simply tells that the central metal is in the atomic state itself. It's not an ion, it is an atom. Potassium dicyanide, dihydroxide, nickelate. Last one more example under anionic complex, Na, Ni, NH3. Okay, NO3 twice Cl. Now in this NH3, okay, it's ammonia molecule, but as a ligand, its name is amine with double M, and it is compulsory to write that double M. Its charge is 0. It's a neutral ligand. Now, NO3 is actually NO3 1 minus, yeah, and it's our nitrate, but as a ligand, its name is nitrato. Nitrate is called nitrato as a ligand. Then moving on with the name, this is sodium. Okay, amine nitrato chlorido. So the alphabetic order, the first one will be triamine. amine. C comes in the alphabetic order first, right? So triamine chlorido, triamine chlorido, dinitrato, dinitrato, the charge +1 x 0 minus 1 into 2 minus 2 minus 1. So x minus 2 is 0 and therefore x will be 2. So that's all in this episode regarding nomenclature of anionic complexes. Stay tuned for more videos. Thank you.